Hey guys, welcome back to the channel. I have an interesting video. This is in 2011. Sorry, actually, let me just get you the correct information because it's not a 2011. I was going to say 2011. It's a 2008 Mini Cooper R56 with an N12 engine. This is coming from here, Virginia. Larry, this is your computer. So he sent me an email about having issues with his computer. And let me just read it 1 second. I'm just going to go over to the inbox so I can read his email. Larry right here, because we have been in a few conversations. Actually, I think I have the paperwork too. And right here. Okay, so he sent this on the 21st, and I've been actually holding a little bit on the computer because I wanted to do a complete setup. I cannot see if you guys are seeing me or not. Yes. A complete setup because, as you see here, I have not just a computer. I have the throttle body, the accelerator pedal. So that's the throttle body and the accelerator pedal right here. You can see it now in the screen. I also have the eccentric shaft and the valvetronic motor because the problems that he was having. So let me see the back. He said it's an engine crank. The tachometer needle registers RPMs, no spark, that doesn't run. Voltages on the DME relay R56, but still no spark. Foxwell, read DME relay voltage error. I noticed a sluggish valvetronic code prior and replaced the servo, but it reappeared. Unsure it related to the failed ECM. Well, so yeah, I'm going to show you a little bit of again slowly how I got the computer open up because he said he has no spark. So I went and checked all the drivers for the coils and injectors because I mean sometimes some misfire and customer tells me it's no spark, and it's actually because no injectors. Because remember this, if by any chance the actual strategy is if the DME see there is no spark, it will kill the injector. But sometimes it can happen both ways, right? If it's no injection, sometimes it kills the spark. But I'm just trying to always not think or no that never happened, and I always check. So I check injector drivers, the coil drivers, and the actual DME is working good. I don't see any problems with the DME whatsoever, especially now that I have a complete setup. I have also let me see if I turn this off. Yes, I have the wiring diagram. This is specifically with his being number and everything. So this is not a generic. This is actually from BMW Mini Cooper. So what I wanted to see is how the computer is getting powered for the valvetronic, because the computer, if we see here on pins 1 and 2 and connector X60211, which is the center connector. Let me just go back to here. So I have a mark so you can get to see the numbers. There are two different numbers. That's what I had: 232, 12, 232, 11, and 04. So the X006004 is the first one. Then it depends on the model, and the connectors are pretty much the same, are the same, but the internals are different. Okay, I was saying if the connectors are the same, but the pins are different. Let's say on this computer, the eccentric shaft are in the same connector that would be otherwise for injectors on other computers. So connector 12, connector 11, and connector 04. Let's just go by those last numbers so we understand what I'm seeing in here, or what we're seeing here. So 04, we got the power for the valvetronic on pin 2. And then the valvetronic servo motor, which is this one right here that I'm pointing. You can see me here, that little big motor in here. It's using a 40 amp fuse. So this draws a lot of amperage. My power supply can supply up to 50 amps, so that's not a problem. I just need to run a special wire that I have it in through a different connector, and then I am supplying the power. So, but yeah, as you can see, the computer is in complete control from ground and power for that servo motor. And also has the eccentric shaft, which is the one with all these pins in here. It's a 9-pin connector. So if we click in here, not sure what I'm getting. Oh, I know why I'm doing that. Is because, give me 1 second, guys. Yeah, I was clicking in the wrong screen. All right, so I was saying, if we look at the connector for the eccentric shaft, it's a 9-pin. Only 8 of those 9 pins are being used. And this is the way that eccentric shaft connector looks. It's a little weird here on the diagram. Like, oh, it went over too much. Full screen. Because if we see here on those two last pin, or right here on pin number 4, look at that red arrow. It's not connecting those two pins. Not sure why. I went over to the pin outs on the DME, which I have in here too. It says 30 as in the DME connector, 12 be in the ground for the servo, for the eccentric shaft. And we can see those in here as well. If I click in here. Come on. All right. So we're going to pin assignment. Again, connector, I can move these this way so we can still see that here. So connector 12, pin 30, right? So I'm just going to scroll down to that one. So right now we're in connector 12 and pin 30, it says ground eccentric shaft sensor. So we know, and I know that all my connections are correct. So the rest are signals, and I have all the wires and everything connected properly. Again, if we go back to here and I zoom out a little, then you get to see that servo motor right there. And then the eccentric shaft. This is the eccentric shaft original for Mini Cooper. So this is the way that looks, and it has, again, 9 pins. Only 8 are being used, and I connect everything properly in here. And the reason I didn't use a connector is because, again, this same harness will be used for injectors in another different type of motor, or the newer one, where the valvetronic and the eccentric shaft are built into one, and then it's a different connector going into another harness. But that is, it's just for another Mini Cooper. But as you can see, I got everything ready, connected, and so on. All right, so let's go over to, I guess this, we can use either capture. I'm going to, let me get into the screen where I can see. I want to put the tab done, which I have connected. So I also want to show you on the tab done, like these are the codes that we have now. So there is no valvetronic and no eccentric shaft faults. When I got the computer at first, like if we go here to home and I go over to, let me see if I can move this. Yes, I can. I got to go back to the first screen. Sometimes a little hard to move with this. Okay, we got data manager. So as you see, I got 3 of the same Mini Cooper. The last digits on the big number on this car is 7427. So I'm going to go to the first one. If I enter these, and you can see, let me see if the date is here. Yeah, 2521. So this is when I got the computer. And I immediately connected, and we have the valvetronic adjustment range, eccentric shaft sensor guide, and eccentric shaft sensor reference. So all those 3 were there. Then we have, that is on the 25th, no data, no faults. And then I went and tried to, get a little more. And this is what we have now with no valvetronic. And I can, disconnect wires, which will reproduce the same problem that we had before. Let's say, and let's do that so you guys can see what would happen if you lose voltage or so. So I'm going to completely get out of here. We need to wait for the scanner to finish reading the codes. All right, I'm going to exit completely. It's going to I did a vehicle really quickly after this. So I'm going to turn everything off, including this output here, but I'm going to unplug the wire where I am supplying the power. All right, so this wire that you see right now here is the supply for the valvetronic. That is the pin 2 on the connector X604. I'm just going to leave it hanging in here. And now I'm going to turn the power back on. Power the computer. And you can probably, look at the scanner immediately, ID in the car. I can also show you, if I move the camera over to here, let me get not sure if I can do that with here. No, because I have it in a different window. I have to do it by hand when I have it like this. But if I power this off, hopefully you're able to see that throttle body moving, and it's because we just turned the computer on. So when you turn the computer on, it's going to read the position of the throttle body to see if the sensors are all reading good or not. And that is the same thing it does with the eccentric shaft and with the valvetronic as well, because those are main players. Otherwise, the car will not start. If you have a problem with the throttle body, you go into limp mode, and most likely will start. Especially if you're missing one sensor. If you're missing more than one, no way. The accelerator pedal, on the other hand, right? So if I move this, hopefully you can see there the throttle body moving. And it's not going to open completely because it's not completely in a test or anything, right? But you can see that is working. So, and that is completely normal. All right, so let's go back to, no, not that capture. I actually want to just put the ultra. And let's enter the car. I'm going to do it by hand so I don't have to be going back and forth screens. So we're going to select the Mini Cooper one more time. It's going to try to read the entire vehicle. It's going to tell me to turn the ignition off, and I'm not going to do it because it's not really needed here. But you saw in there R56 N12, and that is the 7427, which is Larry's VIN number. Very important, Larry, in your car that you check that eccentric shaft, because I think that either you have a problem on either one, the valvetronic or the eccentric shaft, because they're interconnected. You see, I didn't wait for that ignition to go 10 seconds. You need to do that in the car, like that the computer or the scanner will read all the modules. I don't, because I only have the computer here. Either way, it's going to say the communication is faulty because it cannot find the rest of the modules. And that is completely normal. By the way, I forgot to mention that if you're doing a test like I am here, you need to make sure that you add a 60 ohm resistor in the pins 6 and 14. Otherwise, it will not communicate. All right, click OK on that. And you see that we'll talk. Just wanted to have the scanner a little bigger because, that's the most important information right now. And again, I didn't find any problems with the coils. I'm going to go over to the coil supply so we can understand in Larry as well where the power is coming from, because it realistically goes only through the DME. It's not really controlled by the DME, and I'm going to show that in a second as well. Because I don't really understand why BMW or Mini Cooper did that, but it's just a jumper. Realistically, the power comes into one connector and it goes out into another pin of the same connector. Again, we'll see that in a second. All right, so we're going to move this so I can get the scanner a little closer. All right, let's read trouble codes. All right, so I want you to see that third fold. 2860. 6C. Yeah, 00286C present. Digital motor electronics valvetronic power supply actuator motor. You see, this is why, because we had this wire now unplugged. Before we didn't have that fault. And if I go back, that fault will go away. So is that something wrong in the DME? No, not at all, right? And this is what I want to show this because it's important for Larry. All right, so let's go back to wire diagrams because I want to show you again coils. So we are here on this. Let me close this, and so you will be able to see when you are here. If you're not too familiar with Mini Coopers or so, are you going to get this is your first window right here, vehicle information and so on. If you're doing diagnosis, you can go into control unit 3. I don't have the car connected. I'm looking for information. So I'm going to click into vehicle management. I'm going to go into troubleshooting, function structure. So, right, if I click on component structure, I will have to go into each component. If I go into function structure, then I can click into powertrain. This is the way it will be, right? So this is like how it will show up. So I'm going to click on powertrain in the engine electronics, and then I can click onto anything that I want. Before I was into valve gear because that's where the valvetronic and so on is, right? So valve gear, SSP is wire diagrams, and FUBs are function of operation. So you can read how it's designed and what everything works, and probably it's a little good if I show this as well. Hopefully you like the information. This is again the eccentric shaft. And this is the one that's going to tell the computer if the valvetronic move or not, right? So this is why it's so important that this one is checked. This is very common that fills with oil and it damages the sensor and the connector. So make sure the connector is not full of oil. And then we have, again, the valvetronic servo motor, which is just a 2-wire motor. Computer might look into amperage in here, but power is mostly what it does. Like in here, there is no power, right, being supplied to it. And then we have the intake camshaft, exhaust, and intake camshaft sensors, right? Very important because it's in control of like position, or not in control. It knows the position of both. And then we have then the Vanos solenoids, which are going to be the ones moving the actuators to control timing. All right, so we can close this. All right, let's go into ignition coils. So right here, ignition, and then we're going to go into ignition coils. So this is because he was saying that he does not have power. So reading here has no spark nor run voltage in the DME relay, but it's still no spark. So again, I'm not sure without voltage. So without faults, what could be the issue that you have? He said that again, he has valvetronic faults. Valvetronic faults, the car will put itself into a no start condition because it doesn't know where the timing is. So if you have problems with that, it might kill the car with no start. So this is very important. So again, if we see here in connector X604, pin 1, right? And that power is coming from a relay that he mentions in here, the 6326. He put this into his notes. Let me just show you that in a second. Let me get this out of the way. But if we read in here, he mentioned that relay 6326, which is correct. And that you can have power in here. It would have to be burned inside the computer. I'm going to show you, remember. So it's saying that it comes into pin 1, and then the supply for the coils, in the other hand, is right here on connector 11 and pin 5, right? So what I want to do is I'm going to turn the computer off 1 second, and I'm going to get a multimeter. Let me get that camera close. And I get into connector views because that I need to see Pin 1 and pin 5. Well, realistically, I think I know where they are. You can see a little bit of a bend in here. Could be being handling this or not, I'm not sure. All right, so but what I want you to see is this. Pin 1 on X604 is right here. I'm going to turn my meter on. And I'm going to put the continuity. And diode, continuity. Make sure you guys can hear that. All right. Always check your equipment before you do tests. I'm going to flip this. Hopefully, yeah, we can hear. Not sure how much you can hear that beep. All right, so let me just put the camera because sometimes the microphone eliminates the sound. Okay, when I don't touch the cables, we got, an open line. When I touch it, we got resistance, right? So pin 1 is here, and that pin, let me go back to the diagram, at least myself. The other one is pin 5. So pin 1 and X604 and pin 5 on the 11. Pin 1, pin 5. You see what I mean? And it's not because these connectors are connected, because I'm going to unplug this, all of them. Because you might say, well, they might be doing continuity because you got the connectors installed. Again, you can see resistance almost zero, right? 0 ohms. That's a dead short. And that is a dead short. Look at that, 0.11 ohms. Why? Because all these wires are in here is coming in pin 1 on the DME, and it goes out into pin 5 going over to the coils. The only way that those coils will not get power, it will be that these two are burned. So this is just a jumper in here. There is actually nothing connected to the DME. This doesn't even go. Again, I want to show you that. So we have that jumper that I was telling you. See that metal piece in here? They're completely welded together. So this is a one piece. And there is no connection from this pin down to the board, and neither one on this other one too, like all the rest. You see how these ones are, these are pin and goes down into the board, and there's solder on here, right, on the other side, right? It's like, let's say, this is pin 1, 2, 3, 4, 5, right? Pin 2, it has these two little, metal pins that go down into the board, and they're soldered on here, but pin 1 does not exist. And then on connector 11, pin 5 does not exist inside the board. There is, again, nothing in there. So I just want to address that because a lot of people are like, no, it goes inside the DME. Well, yes, it is going inside, but it doesn't even really touch the board. Not sure why, again, they decide to do that. I mean, this is a secret of engineering, let's just say, right? Because they shouldn't even bring those cables inside here because they're not supplying any power for the DME whatsoever. So there's absolutely nothing. As you see, it's not even touching the board. So they're just bringing a wire in and a wire out. No idea why. All right, but okay, so I got everything back together, connected, and we can see that, again, those two pins, they got no connection whatsoever in the board. So I'm not sure what it could be happening with your vehicle, Larry. I have spent realistically hours trying to finish a harness that I didn't have done for that eccentric shaft and that for that valvetronic, to make sure that I give you a correct answer, because when I do something, I don't like to do it halfway. If I'm going to give you an answer that your board is working good, it's because, as you see here, I have done a completely throughout inspection and I cannot find anything wrong in here. So I'm gonna have to deem your computer as good. And I hope that also you like this, and all of you that are watching the video too, because I just don't jump the gun into repair a computer and charge a customer, because I mean, you send these to, let's say, pretty much the rest of the facilities that repair computers, because there is a lot of scammers on this country, and I'm sorry to say that, but it's just the truth. And they tell you, oh no, we put this on in a car and it's running good. Yeah, let's watch one of my videos that I just did from a FICM from Russell in Florida. I just put a FICM, but yeah, he sent this to a company in I don't know where it's located. I think it's like North Carolina or something like that. And yes, we connected the FICM over to the car and it's running good. We tested in a running vehicle. He spent hours, hours trying to check what could be he missing, like that the car is not running. He sent me the FICM in here. It's no good. And I'm still trying to revive it, because the problem is when you got a module that comes from somebody else and they're already trying to, steal from you, because realistically, I mean, if you go and watch that video, you understand what I'm saying. This is not the first FICM that I get from the company, and it's a joke. But again, so I don't do that. I try to really take the time, and I can make mistakes because I can just check so much. And this is where I want also people to understand that simulators can also misguide you, because like I have another example. I have a 2010 Ford Mustang Shelby that was sent to me from Atlanta. And I checked it with the simulator and everything was working perfectly. Let me restart. It wasn't working, no communication for me. Was not communication, sorry. Problem on the coil drivers. Another facility deemed it and as not repairable, and then it has a problem on the main processor or in the main IC, and that left that board completely bullshitted. And it's a very expensive computer. Even use that computer is $10,000. So I tell that company, send it over. I'm going to try to do my best. But again, I made a mistake on trusting tools. These simulators, the loads that they use for coils injectors are not exactly what the computers are looking for. So sometimes they set primary to secondary faults, and I was just disregarding those because I see those as normal. As long as I can see a coil firing, I was thinking everything is good. And I did a load test and everything with my conventional way of testing, and it didn't work. I sent that to the customer and like, Mike, I believe in your test and I can see it because you did it really well, but that is still giving us four coils that are not firing in here. So he sent me even waveforms from the secondary and primary coils and all that stuff, and I'm like, send it back. And you know what I end up doing? I'm going to show you a new tool that I did. So this is a little tool that I created myself. This has inside 5 coils with 5 real spark plugs, and I get to send the spark into earth, and I can turn it on and off in here, and I got all the signal for the 5 coils, and I'm going to do all or others to get 8, but realistically with 5 coils I can cover at least 4 cylinders, and then do 4 cylinders at a time. I don't have to be doing one, because in the test that I did for this customer, I did 2 coils at a time because this didn't came on time for me to do this setup. I also did this because you know what? I don't like to get burned. I don't like to give bad advices to customers. These are real injectors that I created. Again, the main power coming in here, which I can connect it over to, my voltage supplies, and then all the signal for the 8 injectors. This is a real load. There is no doubt if it fails, it will fail here. I mean, if I all do all this and I miss something, at least you can see that I'm trying my best to help you. And it can still something happen, right? Because With electronics, it's never 100%, and I can tell you that. But yeah, so what I'm trying to express and show is that I cut no corners. I get the parts that I need to do. I get the harnesses that I need to do to give you the correct answer. If the fault is going away in here, well, you have a problem in the car. I cannot find anything, no problems on the coils, drivers. I'm going to even try to perform, at least an RPM test. I'm going to see if I can provide the RPM signal and see if I can fire the coils, because those are regular coils, and I can connect again. That's the system that I have in there. So let me actually stop the video and see if I can run that. All right, I'll be right back. All right, guys. Yeah, I've been trying to set up everything, but yeah, it is actually not possible without the CAS. Let me show you the faults that I'm getting right now. So, and this is just again due to not having the CAS and the year of the vehicle. I mean, I can try to do workarounds, but that will be a little risky because it's software wise to remove, let's say, the immobilizer, but it's always a risk. And I don't want to take that chance myself just to, perform something that can be done in a car. So in this case, I would either rather talk to the customer and see if he can send me the CAS and a key, and then I can connect. I have a JBE here, and I have, a key reader and all the stuff. So, so I'm going to contact Larry and see which way he wants to go. As you can see, I have no full codes on the actual valvetronic or eccentric shaft. I actually have to rewire my connections because I was using terminals that were not fitting properly, and I was getting I was trying to set up the coils in here, and then all of a sudden this valvetronic servo motor start to spin. When that happens is when the eccentric shaft lost the signal, like 5-volt reference or one of the signals. The motor will start trying to move to locate the minimum or maximum position, which the computer based on amperage can do as well, just at least to get it to a position, and then it stops. But when it cannot feel that, especially here, I mean, it's not connected to, or it doesn't have a way to stop, right? Because there's no cams or nothing. So the motor was just spinning, but that also proves that, the computer is able to move the valvetronic motor, and that is at least a good thing to happen. Right now, like I said, I changed the connections. Let me just show you. Let me remove the ultra from there. But yeah, as you can see right now, I did, well, actually you cannot see, but I rewired, and now this, gets to, yeah. So I put, new, smaller terminals that now fit perfect. And so it's no most loose connections or anything that can happen in there. But, well, actually I can zoom a little out. I forgot that I was too close to that. But yeah, so I even print some stickers for the valvetronic and everything that I want to put, on the motor to make it, nice. I like to keep things organized as usual here. But yeah, so this is to a point that I think is good enough. The tests, I had done multiple of these computers, and you have, if you want to visit or look into the playlist that I have a playlist for Mini Coopers, and I am pretty confident that none of the ignition coils, or not the coils, the drivers are bad. And also, it's very uncommon that all the drivers will fail. You can have one misfire or two misfire, but all the coils at the same time, that is very uncommon. It will have to be a burn, like a burn DME. And that's, as you can see here, it's a nice and clean computer. Communication, everything is working well. So, and I have proved, by disconnecting the valvetronic and some other things, that the logic of the computer is good. So, yep, I think that I'm going to stop the video here. I got like 35 minutes of trying, and believe me, I have spent probably 4 hours trying to duplicate the signals and make it work in here, but without the CAS, it has been just impossible. I even created a harness, which is good, because I now have, the harness for the coils, and I can, put those at any time that I want to when I have a complete system, then I can make it work, because I can show you, I have everything to connect the CAS and to connect the cluster and the JB, and I have all that here. And I have a Mini Cooper that I'm going to be doing a video for Glenwood, and when I'm going to fix a CAS that he has a problem, but he's sending me everything, the DME and everything. It should be here shortly during this week, and then I will show you how that is when you have everything that you can actually do a test. And I think this is a little newer, so I'm going to have to do some tweaking on the harness, and I have more connectors, so that's not a problem. But yeah, so like I said, I think this is good enough. I hope that you guys like the content. I try to show as much as I can on connections and signals and wiring, like I did with the ISTA information that I showed you in the beginning. I have probably not show you. Let me see, what is that? It's here. Why is not showing up? Maybe because I have it. Oh, I know why is that, because I have this view, but if I go here, now you have the ISTA. So again, I show you all the connections that we have in here, and I can show you if I go forward, looking at the throttle body and other signals in here. We saw this before. We talk about the ignition coils and signals, which in this Mini Cooper, very important, that extra ground that is on the valve cover. Don't let that loose, because I will burn the computer. And I can repair it, but yeah, as long as you keep always, when you do any repairs on the engine, put a, I don't know, like a zip tie that you don't, or a rack, and something that reminds you that that ground has to be connected, because it is number one fault. Technicians with years of experience, they replace the valve cover, leave that wire off, go and crank the car. That is a ground for the spark. And if that is not connected, it will go back to the computer and it will burn the computer inside. I mean, again, it's repairable, but you don't want to spend money that is not necessary, right? I also have the signal in here for the crankshaft position sensor. And nice thing about BMWs and Mini Coopers, when you're looking at the wire diagrams, I just went again into the same location that we're here. You go into the same place where we were, but you go into engine speed, and you go into the SSP, again, wire diagrams. This is the function of operation, a functional description, and that tells you, it's just the way it is designed. And I'm not sure if it tells, well, the voltage is supplied to the sensor by the DME. This is very important, because this is a Hall effect sensor. Is a 3-wire sensor, so the computer sends a signal at 12 volts to be pulled to ground. So the sensor itself has its own voltage and his own ground, and by the reluctor moving, when you crank the engine, that sensor pulls that 12 volts to ground, and it creates a signal, which I can also show you. I have multiple informations in here. You're not going to be seeing this, but I'm going in behind the screen. Let's say, I'm going to pick up one that I know is good. And I'm going to show you this capture in a second of a known good signal. We get a little bit of the glitter out, and I actually have to turn this display, Vista, and now we're in the display. Okay, so this is again the cam and crank. This is just with one of the camshaft sensors, but it's a good capture. So I'm going to show you how that signal looks. I'm going to just pick up one event, right? And with Picoscope, we can put a cursor here and a cursor on the same spot at the end of this signal. And then I can do a measurement, and I just can count a rising edge in between the rulers. And then we can see at the bottom, let me just make that a little bigger so you guys can see where it says 58. So it's a 60 minus 2 teeth. And then it's a 0 to battery voltage. So, or it will be, again, they said battery voltage for 12 volts, but it's actually battery voltage, right? And then to ground. So we can see the amplitude of that waveform in there. I can put, more things in here, but believe me, I am reading it right. it is 0 to 2 battery voltage. So that is a correct signal. So again, I'm just trying to get you as much information and share with you as much as I can. I always like to do that when I'm working in a car, not just focusing into what I'm doing, also sharing so you can understand how it works and how the signals are being brought into the computer, find references and sensor grounds and so on. If you need to learn or want to learn more about that eccentric shaft and the signals, because that is a very intricate signal. And we can see that. Let me go back to the capture of ISTA. 1 second. Oop, turn it back on. So I need to get into here. If we go back to where the eccentric shaft signal is, which is, let me go back right here. So let me go full screen. And if we click on, actually right here. No, that's not what I want to check. 1 second, guys. I'm a little exhausted from, well, those are the connected positions on the computer since I click on that. But what you want to do when you're here, you click on overview. Again, that's going to let you see all the lines and components that are here. So if we want to know which, what is each of these signals, like this T, yeah, it might be a little small for you guys to see, but there's nothing else I can do as far as zooming in, not in ISTA. So the second line in the wire, it says T-2S1. If I go to that one right here, which is T-S1, I can click in there. Well, actually, I was able to zoom in. So if I click in there, all right, so now you guys can see it better. It says signal eccentric shaft. So the next one, PCS2S. So PCS2S is a signal, right? So if we count all those, we're going to see, I can zoom out a little bit. Let's zoom out a little more. Just a little more. I just want to make sure that we got all the signals in here, and we do. So what you're going to have in this sensor is going to be pin 4 is the ground. And let me find the power, which is usually an M. Let me just see. No, sorry, it could be a U. Yeah. So the U arch, oh no, let me see, U, BBT. UBBTR, UBBTS1, yeah. So the UBBTS1, which is on pin 6 or pin 20. Let's talk about the pins on the computer. Let me remove myself from here so you can see well. So the first pin right on the computer on the left side is UBBTS1. So UBBTS1 is the power supply for the eccentric shaft. Then the ground is the last pin, which is not even, it doesn't have a number, but if I go over to, pin 30 with the pin outs, we saw that before, that is the ground for the eccentric shaft. And then we will have 1, 2, 3, 4, 5, it should be 5 signals. Oh, let me see, MBBTS, so because it should be only 5 signals. MBBTS, oh, it's actually another ground in here, so pin 19, we have another ground. I'm wondering, because I was looking for to see what else is in this pin 4, because you see how this wire is not connected in here? It doesn't tell me where this 30 goes, because if I go to, again, the pin outs, which we can revisit again. So let's go over to the connector X60212. No, got to go full screen and click on the X6000, which is the DME. I click on the connector, that will just give me the views. All right, so we know that we are in connector 12. So again, let's go down to connector 12, pin 30. And it says ground for eccentric shaft sensor. So it looks like it uses 2 grounds, not sure why. On the screen. So we will have then power on pin 29, ground on pin 19, and on pin 30. And then 5 signals. There are 5 position sensors in here. So they're all going to be named just signals and signals and signals. If we go over to the overview again, we can pick up either one, right? So we check the first one. Let's go in order. So 28 PCS1S1. So right here it says PCS1S1 signal eccentric shaft sensor. If we go for PCLKS1 signal eccentric shaft, you see what I mean? So I just tell you there is a signal. So there are 5 position sensors. So this eccentric shaft is in control completely to tell the computer, which I think is like a 2 degrees of difference, because again, this is the way the engine breathes and controls the valve timing to get the engine to breathe and accelerate. The throttle body is normally open and it's just there for emergency. So in case the valvetronic fails, it will give you a limp home mode, kind of like a little bit less acceleration, then you can continue. It all depends on how much it fails. If the valvetronic fails completely, the car will like let you drive through the point that when you turn the car off, it will not start again until you replace or repair the valvetronic issue. And I have seen that in N55s and N20s and N26. So all those engines will have the same problem as well with the valvetronic. Any of the BMW valvetronic systems. This is an old style. Not that common to have this loss of spark like he was saying. So, but again, it's a little hard to go that broad when you're trying to describe everything for all these European vehicles, Mini Coopers and BMWs. All right, guys. So again, I don't want to make this too long. It's already long, but I'm trying to, do the correct tests and give you as much as information as I can, as I usually do. All right, guys. I'll see you next time. Bye-bye.